Hello, my brilliant students, and welcome. How are you all doing? If you're getting ready for your WAEC, NECO, or JAMB exams, then you are in exactly the right place. Today, we are going to tackle a topic that I know can seem a bit tricky, but trust me, it's guaranteed to fetch you some serious marks: carbon and its compounds. This is pretty much the foundation of organic chemistry, and my goal today is to make it super simple, super clear, and get you absolutely ready for your exams. So here's our game plan. We'll start with why carbon is such a special element. Then we'll dive into its unique abilities, words like catenation and allotropy. After that, we'll break down hydrocarbons. And the best part, we are going to solve real past questions from WAEC, JAMB, and NECO. Everything we're covering today is pulled directly from your syllabus. We're talking Section D for WAEC and Topic 10 for JAMB, so you know you are learning exactly what the examiners expect you to know. Alright, so what makes carbon the king of elements in organic chemistry? Why does it have a whole branch of chemistry named after it? Well, it all comes down to a few unique abilities that allow it to form millions, literally millions, of different compounds. That's more than any other element. Let's break down these superpowers one by one. First up is this big word, tetravalency. Don't let it scare you. Let's break it down. Tetra means 4. Valency is just about its ability to form bonds. So tetravalency simply means that every single carbon atom can form 4 strong covalent bonds. Think of it like it has 4 hands ready to grab onto other atoms. It's like the ultimate connector, a Lego block with 4 connection points, letting it build these massive, complex structures. This is the first secret to its power. Now, you might be wondering, why can it form 4 bonds? Well, this right here is the reason. Carbon's atomic number is 6, which gives it this electron configuration: 1s2, 2s2, 2p2. Now look closely at that second energy level. That's the outermost shell. If you count the electrons, you've got 2 in the 2s and 2 in the 2p. That's 4 valence electrons already in waiting to form those 4 strong bonds we just talked about. Simple as that. Okay, next up is catenation. Now I need you to remember this word because it's carbon's ultimate superpower. Seriously, it's the amazing ability of carbon atoms to link up with other carbon atoms to form these incredibly long, stable chains, branch chains, and even complex rings. No other elements can do this nearly as well. So what does this mean for you in an exam? If you ever see a question asking, why are there millions of organic compounds? Your brain should immediately scream, catenation. It's the answer. Another key concept you absolutely must know is allotropy. This is when an element can exist in different physical forms, even though chemically it's the exact same element. Carbon is a master of this, and its allotropes have completely different properties, which makes them perfect for those compare and contrast questions that examiners love to ask. Let's look at the 2 most famous ones. And here we go, a perfect example of allotropy in action. On one side, you have diamond. Here, each carbon atom is bonded to 4 others in a super rigid, tight tetrahedral structure. This is what makes it the hardest substance we know, and also a very poor conductor of electricity. But then look at graphite. The carbon atoms are arranged in layers that can actually slide over each other. This makes it soft and slippery, and because it has free-moving electrons between those layers, it's a good conductor of electricity. You need to know these differences. And it doesn't just stop with diamond and graphite. There are other forms too. We have amorphous forms like coal and charcoal, which don't have that neat regular crystal structure. And then there are the more modern ones, the fullerenes, like C60, which has this incredible structure shaped just like a soccer ball. Cool, right? Okay, so we've seen what pure carbon can do. Now let's see what happens when it starts bonding with other elements. We'll start with the simplest case, hydrogen. This brings us to hydrocarbons. These are compounds that contain only hydrogen and carbon, just those 2. They are the absolute fundamental building blocks of all organic chemistry. Now, we classify hydrocarbons into 2 main families. First, you have the saturated ones, which we call alkanes. The key thing here is they only have single bonds between their carbon atoms, and they all follow the general formula CnH2n plus 2. Then you have the unsaturated hydrocarbons, the alkenes, which have at least one double bond, and the alkynes with at least one triple bond. Their formulas are CnH2n and CnH2n respectively. Guys, you have to lock these formulas into your memory. They are non-negotiable for your exams. Okay, time for a quick check. This is a very typical exam style question. If you have an alkane and it has 5 carbon atoms, what is its molecular formula? Take a second. Think about that general formula we just looked at. Let's solve it together. Step 1. We grab the alkane formula, which is CnH2n plus 2. We know there are 5 carbon atoms, so our N is 5. We just substitute that into the formula, C5H2n plus 2. A quick bit of math. 2 times 5 is 10, plus 2 is 12. So our final formula is C5H12, which we call pentane. See, you can totally do this. Alright, here's another common task, balancing combustion equations. Hydrocarbons are fantastic fuels, and when they burn completely in enough oxygen, they always produce carbon dioxide and water. So, your job is to write the balanced equation for the complete combustion of ethane, C2H6. And there's our solution. Now, the key to getting this right every single time is having a strategy. A common mistake is trying to balance the oxygen atoms too early. Here's the golden rule. Balance the carbons first, then balance the hydrogens, and always leave the oxygen for the very end. That one tip will save you so many marks, I promise. Now, how can we tell in a lab if a hydrocarbon is saturated or unsaturated? We use the bromine water test. This is a classic. When you add reddish-brown bromine water to an alkene, that double bond breaks open and the bromine gets added across it. We call this an addition reaction. This makes the color just disappear. But alkanes, since they are saturated and have no double bond to break, they don't react, so the color stays. You need to know this test inside out. It's not just theory. This could easily show up in your WAEC practical exam. Alright, you've learnt the theory, now it's time to put it into practice. This is the most important part, applying what you know to real past questions from WAEC, JAMB, and NECO. This is how we figure out how the examiners think. Let's go get these marks. First one up is from WAEC 2018. Which of the following is not an allotrope of carbon? Okay, let's think. What's an allotrope again? It's different forms of the same element. Graphite is pure carbon, diamond is pure carbon, fullerene is pure carbon. But methane, what's its formula? CH4. Ah, it's a compound of carbon and hydrogen. So the correct answer is D, methane. Easy marks if you know that definition. Next up from JAMB 2020. The property of carbon that allows it to form a large number of compounds is... Okay, now tetravalency is important for sure. But what's that specific property that allows for those super long chains and rings leading to millions of compounds? It's B, catenation. See, I told you JAMB loves that word. And finally, a theory question from NECO 2019. Write the structural formula for propene and state one industrial use. Let's decode that name. Prop tells us there are 3 carbons. The ene ending tells us there's a double bond. So the structure has to be CH3CH double bond CH2. And for its use, well, it's polymerized to make polypropylene, which is a very common plastic used to make everything from chairs to ropes to containers. We have covered so much ground. You guys have done some fantastic work. Now let's just wrap everything up with a quick summary and some winning tips to make sure all this knowledge sticks with you on exam day. Here is the perfect summary slide. It's got all the key terms we talked about, tetravalency, catenation, and those all-important formulas for alkanes and alkenes. I seriously recommend you pause the video right now and take a screenshot of this. Use it for your last-minute revision. This is a high scores checklist right here. And here are my personal tips for you. For WAEC, Please make sure you can draw the structures neatly and clearly. For JAMB, master the definitions. Words like catenation and allotropy are basically free marks. And for NECO, get really good at practicing those combustion equations. This topic can be your best friend if you prepare for it properly. And to make sure you've truly mastered this, I'm leaving you with a little bit of homework. Try to answer these questions on your own. For the full, detailed, worked-out solutions and thousands more practice questions, make sure you visit ExamKP.com. You can do this. If you found this lesson helpful, please do me a favor. Like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB. And please subscribe to our channel right now so you don't miss the next topic. Also, visit ExamKP.com for thousands of free practice questions and answers. Let's smash these exams together.